While looking through the workshop manuals for the 104 this morning, I stumbled across a couple of interesting things I never thought of investigating. Number one, in regards to my alternator, having driven for 2 hours last time and it's still not charging my battery up to a satisfactory level. Battery's charged now, by the way. I just put it on my smart charger overnight since that drive and it's perfect now. But I never thought of actually doing this test just to see if there is a diode failure in the alternator. When that happens, you'll generally get flickering lights and it's pretty obvious. I don't have anything like that, but what the hell? I've got the tool, I might as well test it. So that's a DC clamp meter and it connects to your oscilloscope and it allows you to actually see the current on the screen. It's much more visible than just using a multimeter or a handheld clamp meter. You won't have that kind of display on the vast majority of them. It was just going to be a numerical display and probably refreshing far too slow to see anything like that, because it's going to be pretty fast. It's in relation to the rotations of the alternator, that frequency there. So what you want to see is this. You don't want to see that. So we'll have a look at that. And the other thing I want to do, I want to test my knock sensors because I'm not happy that it was knocking the last time I drove it. I've since had a look at the knock sensor harness. It's not been chewed by rats, but it does seem to be made of that horrific biodegradable nonsense. That's the only thing that is on that car, it seems. All of the plastic is falling to pieces on the outside of the coax cable going to each of the knock sensors. Now the inner core is insulated by a different kind of plastic that's not compromised, but the screening copper wire has all gone green from corrosion, so hey, it may actually be broken in some places. In any case, that's fairly easy to test, again with the oscilloscope. I've proven that on the bench with my other engine's knock sensors. You just basically simulate a knock event by tapping on them with some kind of metallic object and you'll see a voltage generated from each of those knock sensors, and each of them is connected to the 3-pin connector at the EZL. So that's pretty easy as long as I can actually get access on the M104. Front one's pretty easy to access at the front there. The rear one is kind of a pain in the ass because it's right where that big ass oil filter housing is on mine that also has the coolant to oil heat exchanger. That's deleted on red, but unfortunately it's still on blue-black and it is functional, so it's going to be in the way. M119 would be easier. That's nice and accessible, but anyway, I'll see what I can do with this. So on the knock sensor harness, pin 1 goes to the screening on the coax cable to the both knock sensors, and then pin 2 is for knock sensor 2 and pin 3 is for knock sensor 1. I went ahead and made this little breakout device from an old EZL because I didn't have anything to fit into those pinholes, and that worked quite well. Then it was time to do the test. So that's the left side knock sensor rigged up to the scope now, and I'm just going to tap on its plastic housing because that's pretty much all I can access from here. It's quite a nightmare, even locating a light to see what you're doing, and I didn't actually touch it for quite some time. You can see that I start getting to it now, and you can see the knock sensor is producing a voltage when it's being tapped. So that is not deaf, that is working. And then I moved on to the rear one, so I've changed the way that's connected up. Oddly enough, that one's a bit easier to access with the screwdriver. And yeah, that's producing a nice signal as well. So there's nothing wrong with those knock sensors, despite the harness insulation falling to pieces. It still works fine. And now I'm just going to test the alternator. Of course, I've disconnected the battery charger because that is producing a lot of noise. So this is connected and set up in the 1 millivolt per 100 milliamp range on my DC current clamp. And that is the wire from the alternator. You are supposed to do it at the alternator, but I'm too lazy to get down there. And this alternator is looking a hell of a lot like a happy alternator. I'm happy with that waveform, and because of the setting that it's in at the moment, you can shave 1 digit off that millivolt reading, and we're looking like around 17 and 18 amps at idle. Oddly enough, there is no hissing noise with the car just started up recently. I suspect it's the throttle body expanding and leaking on a very long drive, because I don't normally hear that noise, and it's probably just a bit of wear in my throttle body. And you might remember this piece of rubbish W210 E430 that I looked at a couple of months ago. No, I didn't do something crazy like buying this particular one, but I did happen to see one in fantastic condition for sale in Queensland while I was away overseas working. So I jumped on it and bought it, and it's actually on a boat on its way to Western Australia. Reason being because of rail issues to Western Australia, it had to go by boat. So I should have that for next weekend. And don't worry, it's nowhere near as atrocious as this. It has been kept in a garage, and it's most of its life. The paint is not peeling, interior is not baked, and it's only done 130,000 kilometres. I'm not sure what I'll do with it, but I'll probably just keep it in the collection.